All right, there we are. Good morning and welcome to this session. And again, congratulations for making it today after the party of yesterday and a very long and busy week. I'm going to switch up the screen just before we start, just to relate a story we have with a customer. It's Regeneron Pharmaceuticals. They produce medicines, and as you know, when you produce medicines, time is the essence of success to save patients. They had scientists working on top tech equipments, but those scientists, they had literally to be in front of the equipments to collect the data, the results of the equipment, of the experiences. And as they have to move to next step in the experiment, they have to literally sometimes move into a different lab. A lot of times lost by that. And when they decided to change this waste of time, they contacted Splunk, and basically we worked with them to break this cycle of data silos. So they were in a kind of data garage where you pile up your data in silos, and my garage is probably one of the worst garages in the world because I have so many things packed everywhere, but when I want to pick up the bodyboard for my kids, it takes time to find it. And they were more or less in the same situation. They knew they had those data somewhere, but to retrieve the data, it was complex. So calling Splunk to build a unified data platform helped them to reduce the time to develop those medicines. They could access the data remotely, even build a data dashboard, explaining the situation and the progress of the experiments. So really, today, welcome everybody. The topic of the session is to talk about Splunk and data management and to put that into perspective with real use cases and customer experience, and also to talk about what is going to come next. My name is Johan Le Chevalier. I'm an architect at Splunk. I have more than 6 years in aggregated experience on Splunk. I've been professional service before, being an architect, and use Splunk in other contexts. So before we start with Splunk, we have this forward-looking statement, which in essence explains that anything which is mentioned from the roadmap may change or be delayed without us to have to provide any further explanations. You know how it is, products, sometimes they slip a bit. For those who are not familiar with Splunk, and I have some customers here who are experts, so I know they will not necessarily have a lot of things to learn from this first session, but I will explain a bit more in the first part what Splunk is and what it does and what the benefits of using it, before we look into more advanced techniques to manage data with Splunk, and how we create pipelines in those advanced techniques and optimize data flow so that you get better experience and better performance and cost optimization on your storage. And then we will look at what's going to come next. We will finish by questions, so we are going to keep the question for the end. But if we don't have time to cover all your questions, I have some time after the session so we can very happily continue the conversation. So first things first, Splunk, what it is. So your data produced by applications or infrastructures in your data center on-prem or in the cloud, they are under many different forms. They can be collected from Splunk agents deployed on the edge or collecting them from the cloud, and we can collect data, metrics, logs, events, and traces, sent into Splunk and unified into what we call indexes. Those data, they are not really fancy. If you look at them, it's just things that the developers may have put into their application and writing on the logs. But if you take a closer look, they contain a lot of valuable information. So for example, here we have in this the example of a web server, we have an IP address of a user connecting to the service. We have the product type, we have the country code for the language used on the interface, and we also have the browser type, which has been used to connect to this web service. So those logs, they have a lot of value, and when they are sent into Splunk, we can consolidate them into what we call indexes and apply source types on them. And the source types we apply on them permits us to extract the fields and to map that field to the value when the data comes into the system. It's what we call the schema on the fly, which means that the data, they don't have a proper rigid structure like you would have in a regular databases. Here, it's you defining what data you want to pick up, and from the fields you have created, you can create searches where you can filter the data, only pick up a part of the data, or you can transform, clean the data, and aggregate the data. And once you have done that, you can have statistical views. You can create tables, you can create charts, time series, and those aggregations can be consolidated into dashboards that you can share with your team or your management or different parts of the business so they can understand what is going on in real time on your system. The searches that you create, you can execute them in a ad hoc basis, so in real time on the system, or you can schedule them. And when you schedule them, you can create alerts based on the number of events that they return, and those alerts can be sent in emails, in events, webhooks, and so on and so forth, and even up to send to your mobile phone as well. So when we understand that Splunk is the unified data platform, the data that you collect from multiple sources, they can be used in many, many different use cases. It can be used for security, for fraud detection, for analysis of the security posture, and so on and so forth. But they can also be used for ITOps, where you monitor the quality of your services. If you have a production line with different components producing the logs, you can aggregate them and monitor the services of your production line with ITOps. And you can also now, as we have AI workflows developed and more commonly deployed in production, you can also monitor AI. Network operation also benefit from collecting the logs from your different network devices. You have a complete centralized view of what's happening on your network, so your network operational team can have a better understanding of the network situation. And you can have, of course, the developers who can benefit from understanding the performance of their applications as you collect traces and metrics. You can use open telemetry and distributed traces to see the performance of your multiple stacks, and when you deploy a new version of your services, how it behaves, and potentially debug in a better and faster way to troubleshoot and resolve the performance issues. So making Splunk the unified data platform for all your sources makes a lot of sense. But the question is, yes, that's great, send all the data into Splunk. Well, that's super expensive, thank you Splunk, but also does it make sense to put everything every time in Splunk? Some data, they might not be super important. Should we do that? That's a very good question. And it, in fact, underlines the fact that the data, they are not all created equals. Some data, security data, as they land on Splunk, they need to be very, very quickly parsed and looked at. If you have security detections running, you are not going to run a security detection on the data that is 2 years old. It happens now. So as the data they run on Splunk, you need to run the security detection on it. So those data, they are run and read very frequently, and they often have a timeline which is very short, few hours, and after a few hours, they have less value. But during those few hours, you need to be able to run on them. With Splunk and enterprise security, we have detections running every 5 minutes or less. So if your data is not available for the search within those 5 minutes, it's like you run after the horizon. You never catch the security incident. So it's very fundamental that the data for security, for example, they are running and accessible in a very, very efficient way. In contrary, some data are looked at not frequently, with a medium pattern, I would say. And they range from few hours to few months. Those data are used for forensic investigations, ad hoc searches. You are a SOC analyst, and you have an incident to review. You connect on the platform, you make a search. So that's an ad hoc search. And you are going to look at data which are few hours old, once you get the ticket to process, to maybe a few months old. So those data, they need to be accessible, but you are not always going to look after them for these kind of use cases. And at the extreme side of the spectrum, you have the data that you're going to keep for many years, because you have compliance requirements, like you are working in finance. The regulator is asking you through an audit to pull all the transactions for a specific card over 10 years. you will have to provide those results. Otherwise, you're going to get a big fine, and your license may be at risk. So those searches on those data are not frequent, but you need to get them when you are requested to get them. So they are low frequency searches, and those data, they can be kept for a long period of time. So understanding that, the picture is very clear. We have a large spectrum of types of patterns to access the data. We need to store the data from few minutes to many years, and there is not one single silver bullet to do that. We have multiple approaches. So with Splunk, we have the concept of the data lifecycle management of the data. Splunk in itself has embedded a way to move the data across different tiers based on the age of the data. So for example, if you have very, very fresh data, they are usually stored in what we call the hot warm storage, which is high performance SSD storage, for example. With Splunk, we have two ways of storing the data: classic storage or smart store based on S3 buckets. And the data which are highly frequently accessed are usually on SSDs and NVMe cache device, so that those devices provide high performance for the searches. Sometimes you may want to keep those data a bit longer, but it's more often a very short period of time. The data that you are going to access with a medium frequency, they are stored often in what we call the cold storage, which is usually more a SAS or even a SATA type of disk. For Smart Store, it's the backend S3 buckets that Smart Store is going to pull on the cache upon request. And for the data that you are not going to access so many times, they are more often put on data lake, so AWS S3 as an example. So you will be able to read those data when you need them with another product, which is called Federated Search, which is for Splunk Cloud Stack only. So understanding that, let's now have a look on what techniques and what products we have to do some specific data management. So for the people who are aware of Splunk and knowing Splunk, there is an old product called ingest action, which is basically configuring, filtering, routing, and masking regular expressions into Splunk Prime interface. It creates props and transform configuration files that you deploy on heavy forwarders or indexers, which is going then to help you to route the data into specific index or file system or S3 buckets, or to mask and transfer and filter the data. Then comes the more cool stuff, the new things with ingest processor, which is really in the topic of this meeting. And ingest processor, it's a component running in your Splunk Cloud Stack, which is here to help you to filter, to transform, to convert in terms of format, to route the data, to enrich them into Splunk Cloud, Splunk Observability Cloud, or onto AWS S3 buckets. And the last one, which is edge processor, is almost equivalent to ingest processor, apart that it's deployed in your infrastructure. It can help you to filter, mask, transform, enrich, and route the data on Splunk Enterprise, Splunk Cloud, or Splunk or AWS buckets. So looking more specifically on edge processor, it's meant to be deployed within your environment. So you need to put your virtual machines or container to host that service. It receives data from Splunk forwarders, heavy forwarders, HTTP event collectors, or even syslog. And then through the pipeline, which is running onto the edge processor, it's going to send the data into Splunk Enterprise, AWS buckets, or Splunk Cloud. The management of the edge processor can be either in Splunk Cloud environment, if you are using a Splunk stack, or on premises, if you have Splunk Enterprise. And typically, it's on a search head, which is a specific Splunk component. In terms of sizing, this type of edge processor is meant to scale horizontally. So as you get more traffic to filter, you add more edge processors. And usually, if you are using universal forwarders or heavy forwarders, they already have this load balancing mechanism in place. So if you want to send HTTP event to the edge processors, you would have to put in front of them a load balancer, an HTTP load balancer. And in terms of sizing, as I said, it's a scale-out horizontally scalability. So you add more edge processor as you get more traffic. And we usually deploy them on virtual machines or containers. And the size of CPU and memory is very depending on the amount of traffic that they are going to filter. And usually we have some guidance on the web page and documentation. It's around between 2 and 3 terabytes of data per day for one edge processor of 8 CPU and 16 gigabytes of RAM. So talking about his little brother, ingest processor, this one is just only for Splunk Cloud stacks. So it's running within your Splunk Cloud stacks. You have nothing to deploy. So it's ready there. You can send the data as from universal forwarders, heavy forwarders, HTTP event collectors, potentially as well syslogs, but you know the joke about syslog UDP. Oh, sorry, I forgot it. That doesn't work. You don't send syslogs. I mean, it's possible technically, but who is going to send syslogs over the internet? That's not reliable. So the ingest processor can get the same types of logs as the edge processor, apart that it's already deployed in Splunk Cloud Stack. You don't need to worry about doing anything. And in the same way, it's going to run the pipelines and route the data either in Splunk Cloud or on Splunk Observability Cloud or on AWS S3 buckets. So that sounds very exciting, isn't it? How do we do that? How we do what is looking like? So it's not a demo in the sense of a demo, but I'm going to walk you through the main things that's going to feel like you have been through a real demo. So the data management it's a web user interface, which is running either on premises in a search shed or it's in your cloud stack if you are a Splunk Cloud customer. And it helps you to create the pipelines from templates and to deploy the pipeline into ingest processor or edge processor. At the same time, you can monitor the deployment, you can monitor and troubleshoot if you have any problems. And a SPL2 pipeline, which stands for Splunk Processing Language 2 pipeline, is very simple. You have 3 main components. The first one is defining the types of data you're going to capture to apply that pipeline. So the type of data is called the partition. It's based either on the source type, the source, the host, or even the index, if it's already embedded in the metadata, or it can be all of them if you want. Then there is the pipeline itself, which is going to be applied to that partition of data. And the pipeline is just a sequence of instructions written in SPL2, and we are going to come to that in a few moments. And at the end, it is sent into a destination. So that's very simple. The destinations, they depend on the types of, if it's an ingest processor pipeline or an edge processor pipeline, but it can be Splunk Cloud, Splunk Enterprise, Splunk Observability Cloud, or AWS S3 buckets. So I don't want to go too deep into the Splunk Processing Language 2, which has been released globally on Splunk in January, but I'm going to give you a few bullet points explaining the big picture here. There are 3 main parts of the SPL2 that you can use in the pipelines. So the first one is really similar to what you can do with Splunk SPL traditional language. You can filter, you can transform, mask data. So with eval, rex, the where command, the field command, the rename, and lookups commands. So those kind of commands are more often used to reduce the amount of logs. So you need to make some cost optimization on the license, reduce the data. You are going to be more likely to use this kind of commands, of course. Then comes the commands which are more related to manipulating the objects. So if you are receiving JSON or XML objects, you may want to manipulate the objects without complex regular or complex expressions. So you can use sparse, expand, flatten, map, MV expand, reduce, union, and so on and so forth. So pre-built functions to really help you to go through those complex objects. And sometimes you want to reduce the complexity of a JSON or an XML object, or the opposite. You receive some very flat objects, but you want to format them in JSON because it's more efficient in terms of searching, or even if you want to make indexing of those fields straight away. And last but not least, you can use functions such as branch, through, decrypt, encrypt, and your own ones in more advanced use cases for security, compliance reasons, where you want to mask PII informations or payment card information straight away at the edge before to be sent. You can use this kind of information, and that's going to be more for security use cases. So now, looking at the pipeline editor interface. So the first thing when you get into the user management and pipeline editor interface, it's to create the partition, so based on the source type, the host, the source, or the index. And once you have created your partition, you can create a pipeline. And the pipeline, as we mentioned, it's really a series of commands applied to the events before to be sent into a destination. You can create a pipeline very easily. We have more than 58 templates available, and they cover many, many different use cases. So you can pick up a template, and then you can edit it into the editor, which is a web editor. And from there, you can apply the pipeline or visualize the effect of your pipeline on either the samples data that you have provided into it, and visualize the coverage of the pipeline. Or you can capture some real-time events within Jest processor and apply those data to apply your pipeline to those data. So very, very simple. You don't need to have an IDE deployed on your computer. You just go on the web interface, create your pipeline. And if you have any mistakes in your pipelines, you will have a little warning explaining where is the mistake. And when you edit the pipeline, you will have the inline help coming to educate you and provide you the assistance that you need to put those functions in place. You can also have what we call the actions that you put on the data, such as routing, cloning part of it, or even automatically extracting some fields from the raw event. So in a nutshell, you can create a pipeline with a lot of complexity without really writing any complex line of code. All the help is embedded in the interface, making it very easy and straightforward for you to go through it. So looking at a more detailed example, just to illustrate the concept of the pipeline, we are going to look at this pipeline here. And I'm going to take time to come to each step of it. But really what we need to first understand is the intent of the pipeline here. It's to take events which are already in a JSON format, but for some reasons, the source is putting keys with null values. So you have keys, but there is no value associated to it. So yeah, what's the point? No, not a big deal. Well, multiply by the amount of traffic events, it starts to take storage, it consumes bandwidth, it consumes license for nothing. So the idea here is to remove all the keys associated with an empty value very simply. And that's what we are going to show in this example. So the first thing when you create a pipeline is to define what source is going to be used for the pipeline itself. So here, from source, where we have defined the partition, we are then evaluating and modifying a Splunk metadata. So we are changing the index where the data are going to be sent, and we send the data into what we call a JSON filtered index here. And then in the line number 2, we are going to call the function that we have defined to make all this work. And where it's interesting is that this function is either inside the pipeline itself, or it can be from a module that you have developed and that you have shared with your team and imported in the pipeline. And then at the end, it's going to be sent to the destination. And for example, it can be just a Splunk cloud stack. So looking at the function itself, you have a specific way of defining the function that takes the data sent into it. But where it starts to be really interesting is how you can very simply create very complex things. So here, in this single line, we are going to filter from the raw events every single key from the raw event where when we extract the key from the event, we have an empty value associated to it. And in that field, in that line, we have a lambda function which is going to help us to iterate on every single element of the structure to pick up the keys which have an empty value. And it will return to us an array with all the keys which are empty from the JSON event. And from that, very simply, we are going to use JSON delete from the raw event. We are going to remove all the keys which are empty. So in one simple line, you remove all the noise from the event, and that's done. Instead of making very complex for in and this and that, here it's 2 lines of code, and the job is done. So very powerful SPL2 to help you to do very complex use cases, and very simple to do as well, because it's very straightforward, and they help in the pipeline editor. So now we understand a bit more about the theory on how it works a bit more. Let's look at more concrete examples of some data flow optimization. So do you recognize this bad guy? Does that ring a bell? Someone? It's a Windows, yes, exactly. And more precisely, it's a Windows XML event, known for its very high level of verbosity. XML tags, I don't like them, because you have a tag to start the field, then a tag to close it. So it's a lot of weight in the event itself, a lot of space consumed for nothing. And often people, when they see XML, they won't say, OK, let's convert it into JSON. It's more efficient. And it takes less space. So that's the first thing. Here, the challenge is to get the Windows event logs converted into a more friendly and less heavy structure in JSON. But at the same time, when we do that, as we use Splunk and we have enterprise security, we use the Splunk Common Information Model. So we want to convert those events into a log which is aligned already with the Splunk Common Information Model. So the pipeline is going to do that and to filter the event IDs. That makes no sense from a security point of view as well. So at the end, the pipeline is basically just changing the structure of the event from XML to JSON, removing the event types that we are not liking, which have no specific interest, which are just noise, and at the same time, routing the original event converted into JSON into S3 buckets, so that for compliance reasons, we keep that original data somewhere if we need that at some point. And the result can be quite amazing in terms of time, space reduction, and performance. So, of course, you don't take the 17 size reduction as a rule of thumb that you will get every time. It really depends on your data. It will really depend on the filtering of the event ID that you don't want to keep. But when you combine the filtering, you combine the XML to JSON transformation, you benefit from size reduction, so license reduction, and performance improvement at the same time. So looking at some customers who are applying it in real daily use cases, for instance, this financial institution applying edge processor to reduce the data, they managed to reduce by 30% the size of their ingest. And also, having that amount of data reduced, they benefit from faster searches on the system. And where it's really important is that because they have more important data, so they have removed the noise and kept the signal, now they can onboard new data into Splunk to have more coverage and new use cases. Another story from a customer in France, a multinational retailer I've been working with. They had some CrowdStrike EDR logs. So for those who are familiar with CrowdStrike, very, very noisy logs, very noisy. It consumed a lot of space. They were ingesting more than 9 terabytes of data from CrowdStrike EDR alone per day. So quite a lot, to be honest with you. But a lot of that was not really helpful. So applying an edge processor pipeline, we filtered the logs which were use less, and just to keep the important ones. We managed to reduce by 80% the amount of data from CrowdStrike sent into Splunk without losing any security information at the same time. So here, what is to keep in mind is that you just remove the noise, you just keep the signal, okay? So it doesn't affect your security posture, it just gives you more space to onboard new types of logs and to cover more use cases. And it's exactly what they are going to do because they have more space and they can onboard new logs. So very, very straightforward connection between cause and the effects. And last and not least, Autodesk, which is a well-known Splunk customer, by routing the data that they don't need to search after a certain period of time, for a certain amount of hours, on S3, they reduce by 28% the license consumed on Splunk. They access, it's a Splunk Cloud customer, so they use ingest processor, and they access the data on S3 via federated search, which is not covered in this presentation, which is a Splunk Cloud feature only, okay? But it's a way to look and to search on data on AWS S3 buckets. So understanding those techniques and the tools we have within Splunk to optimize the data and to optimize the data management, it makes sense to understand what's going to come next as we see more and more use cases where you need to connect agents to the data, or you have multiple sources of data that you cannot send back into Splunk. So really the idea of the announce behind Splunk and Cisco Data Fabric, which was done in October last year, is to use Splunk as the core component to search the data and provide the data to the consumers. But now with the Fabric, it is about to get access to the data without to have to pull them into Splunk by building connection and federations. So the Cisco Data Fabric is going to be relying on 4 main pillars, so to speak. So the first one is going to be the machine data lake, where you will be sending the data as they are, and based on rules that are going to be defined by you within Splunk, you will be able to promote them into S3 buckets or different formats if you want to look into them, or you can have a streaming promotion, for example, if you keep having to ingest them into Splunk. But those data will be also available for other consumers, like agents or like data scientists want to train models on them. So there will be ways to expose those data via catalogs so they can be found and consumed. A side of that will be what we call AI enterprise for enterprise and Splunk for AI. So we already start to have that into Splunk. We have already embedded some AI assistant into Splunk Enterprise Security, Splunk Observability Cloud, into with the Splunk Assistant for SPL. And more features are going to come with more agents type of features. And we are going to, and we have already started to open the connections for AI to access Splunk via the Splunk MCP server, where you can connect agents to Splunk via an MCP server, and that is already available through a Splunk-based application. Then comes the federated part, where we are going to provide you connectors to outside data lakes, so such as Snowflake, which is in beta actually, and it's a way to consume the data where they are without to have to pull them into Splunk. And last but not least, and that's where I'm going to spend more time now because it's related to data management, are the features which are going to use AI for data management. So the features that we have already covered, I'm not going to come back to them, but we are going to introduce data auto-schematization. So for those who are familiar with Splunk, they know how sometimes it can be complex to onboard data into Splunk. You need to create the props, you need to make the mapping, the common information model mapping. It can take some time to do that. So we are going to introduce a way to automate via AI this process. And we are also going to provide a feature which is called self-healing pipelines that will help you to detect data drift and provide you the solution to correct that. So the auto-schematization is going to work with an AI that is going to look at your data samples, and based on the common information model you would like to apply to those data, it's going to identify all the fields, provide you all the regular expressions to extract the fields, and map them into the common information model you have defined. All of that is going to be done automatically through an AI, and once you are happy with that, so keeping a human in the loop, you will have a proper technical add-on built for you by the AI that you will be able to deploy on your heavy forwarder or on your indexer or search heads, and it will reduce the time to onboard data from many hours to few minutes. So really powerful feature, which is coming in alpha at the end of the month. The alpha program has closed, unfortunately, but if you are still interested to hear about it, we can have a conversation after this call. So I can connect you with the product manager. The benefit of this approach is not only that you will have no deep requirement in terms of Splunk props and regex to do that, but also it's going to bring a consistent way for you to onboard your data, because you may have some variations because of the consultants or the engineers doing that. This approach is going to be providing you a more consistent data quality over time, and of course those data will be consumable straight away into dashboards which are leveraging the Splunk common information model. So data dashboards applications such as enterprise security, but all the apps from the Splunk base which are built on the data models and leveraging the common information models are going to be benefiting from this feature. Then will come this year in April in alpha, so it's a control release again, the self-healing data pipeline for common information model compliance. So here, that's the opposite. Once you get your data sent into Splunk, sometimes it happens that we are changing the format. The source, you have an application which is going to be upgraded, or the developers, they started to put more data into the logs, so the data is drifting a bit. So you are going to say, okay, but you mentioned at the beginning the schema on the fly, that should not be a problem. Correct, that should not be a problem, but sometimes when you extract your fields, the regular expressions you are going to put, they are a bit rigid. So they are not necessarily flexible enough to absorb this data shift. And the result can be a problem, because if you are using dashboard alerts based on fields that you are not going to get data from, those dashboards are going to be empty. So that can be an issue. So monitoring the data quality as it goes over time becomes very fundamental. Here, the concept will be that by an AI agent, you will be able to monitor how the data are going to drift. So it will show you the original data and what has changed, and propose you a way to remediate that. The proposition is going to be explained, and if you accept it, you apply it. So again, it's not AI doing everything for us. We have no control about what's going on. It's a human in the loop. You decide to apply the corrections, and once it's done, it helps you to solve problems very quickly. So what could take days or months to detect as a data drift, because you don't necessarily see that straight away, here it's going to be identified automatically by the agent, and the remediation will be done in few minutes. So it's really here to help to reduce the risks and to reduce the time between the detection of the issue and its resolution. So the main takeaways from my presentation today is really the following one. The data increase that you consume and inject into Splunk is not a question anymore. You need a proper data management strategy to be efficient, to send the data on the right storage, optimize the cost, and keep the performance going on. To do that, we have edge processor for on-prem customers or cloud customers, and we have ingest processor for the cloud customers. SPL2 is a common new version Splunk processing language that you can use in Splunk. searched, or as well in the pipelines for the ingest and edge processors, since it's released on Splunk Enterprise in beginning of January this year. And the Cisco Data Fabric is going to be the next framework to help you to connect the new consumers, the AI workflows, the AI agents that needs to connect to the data, that needs to train on the data. So that's really where we go and what you need to look at coming next. So we can take questions from the audience. Before we do that, if you want to go on the WebEx app, if some questions come after, once you get home, everything is settling a bit from what you have listened, you can go on the WebEx app, join the discussion, and connect to the session. The session is 2278. We are going to monitor and to moderate the space until the 27th of February. So we can keep engaging and getting conversation on WebEx until that. You will have access to the deck. So when you come back to the replay, you will have access to the deck. I've put some resources and links in there, so you can access to the Getting Starting Guide with Splunk SPL2, Edge, and Ingest Processor. If you want to visit us, we have a cafe. I don't know if it's still open now. Maybe it's closed. I don't know. It's closed? All right. So, well, I wish it has been done before, so ignore this part. You can, of course, you cannot book any meeting with the engineer because it's closed as well. But you can visit the on-demand library to collect this presentation. Before I take your questions, really, it's important for us, and I ask that as a favor, to give your feedbacks on the session and on the event. The reason is for Cisco to improve the quality and to target the topics that matters to you, so that your next Cisco Live will be better than this one. And of course, if you complete 4 session surveys, you will get a free t-shirt. And to leave you on this picture, Splunk Data Management is really there to help you to move from this data garage, old style, or Johan style, to a futuristic data, well-organized and solution that helps you to drive revenue, drive business, being efficient, performant, and all of that. So thank you very much for your attention. And now I can take questions. I'm going to give the mic for the recording, and that's it.